Okay, good morning. Today we will going to conduct an experiment on air conditioning. What is meant by air conditioning? Air conditioning is the conditioning of air. Okay, how this refrigeration and air conditioning differs? Refrigeration is not maintaining that atmospheric, the psychrometry levels called humidity of air, dry bulb temperature, wet bulb temperature. Where in the air conditioning we need to maintain that human comfort, so we need to maintain the CO2 level inside the air conditioned room. Also we need to maintain dry bulb temperature, wet bulb temperature for a human comfort. Okay, so this air conditioning is follows the basic law, which is in second law of thermodynamics, Glassier's statement. So this air conditioning basically have four equipments, which are all condenser, expansion device, expansion valve, evaporator and compressor. So the low pressure, low temperature vapor is going to the compressor. Then this compressor will compresses this compressible fluid. Then this high pressure, after outlet of the compressor, the pressure and temperature of the vapor is increased, that is called refrigerant vapor is increased, high pressure, high temperature. Then it flows to the condenser where it loses its latent heat. Then it enters to the expansion device. Then it loses its pressure. After that it goes to the evaporator. Here the phase change will be happen. The vapor is converted into liquid. Then liquid is flows through the expansion valve. It reduces its pressure. Then this liquid flows to the evaporator where it absorbs the heat from the room. Then this heat will be transferred to this liquid vapor will be transferred from the liquid refrigerant is transferred from vapor refrigerant. This vapor is again flows to the compressor. Then it loses its heat from condenser. Okay, this is how this cycle is repeating for air conditioner. For air conditioning, in the inside of the room we will have only evaporator section. Here you can see in the equipment the evaporator is fixed from this side. The condenser and compressor is fixed on the back side of the air conditioning unit. Why we have fixed that in the outer? Because in our air conditioned room only evaporator is there. Because if the condenser and compressor are continuously rejecting the heat, if this heat is allowed to the room, what will happen? The temperature of the room is increasing continuously. The air conditioner will try to cool this room, will take more amount of work. So that from our design we have fitted our condenser and compressor on the outside of the room. But in the case of refrigerator, we will not do like that. Only the refrigerated space is to be cooled. In that we will not going to maintain any psychrometric properties. But in the case of air conditioner, we need to maintain all the psychrometric values like dry bulb temperature, wet bulb temperature, specific humidity, CO2 level, all those things we are very much needed. Okay, so let me start this experiment. Right, now I have started this experiment. So in this experiment we will going to take a reading for evaporator outlet pressure, condenser inlet pressure, condenser inlet pressure, condenser outlet pressure, evaporator inlet pressure, evaporator outlet temperature, condenser inlet temperature, condenser outlet temperature, evaporator inlet temperature, and current, voltage, time for 15 revolution in energy meter, initial temperature and then final temperature, velocity of air. We will going to discuss, we will going to take from this experiment. Okay, so this is how this tabulation will looks. Here you can see that time taken and then evaporator, all those levels are given here for theoretical calculation. These all are used for actual COP find out. Okay, so the formula for find outing the refrigeration COP refrigerator is equal to refrigeration effect, M, how much amount of heat is extracted, which is mass of air and then the velocity of air in the area and density of air. Ti, air inlet temperature, Tf, the air outlet temperature. Because in the air conditioning we will going to conditioning the air, so the air is taken to the evaporator, it flows over the evaporator and the temperature will be decreased. The work output, already we have seen that the X by T into 1 by 17 to 3600. With this we can calculate. So in the pH chart we can find out the theoretical enthalpies, right? Theoretical values of enthalpies, and then we can find out the theoretical COP. So now we can see where is the evaporator, how the evaporator pressure and then the temperatures are going to be measured. Here you can see this is the duct section. This is a duct section. In the duct, the middle of the duct, the evaporator is fixed. Okay, the middle of the duct, the evaporator is fixed. Evaporator coil is fixed. Okay, so what will happen? The air from the room is sucked from the blower. Okay, the blower sucks the air from the room and then it flows over this duct and passes through the evaporator. Then it coming to the, again it circulated to the room. Okay, so we can find out that dry bulb temperature and wet bulb temperature after the evaporator will from these two thermometers. Okay, this is a dry bulb temperature and this is a wet bulb temperature thermometer. The pressures of condenser, evaporator will be taken here. These two green, these two blue colors are mentioning that the evaporator pressure, because in the evaporator side low pressure will be there. For our easy identification, the blue color is given in the pressure gauge. So here you can see the inlet pressure of evaporator is about 60-65 psi. Here also 65 psi. 65 psi and then here also 65 psi. In the condenser it reads here it is in 250 psi and here also nearly 250 psi. Okay, due to that some irreversibilities the value may be changing here, right? Approximately the value is nearer to 250, so we can assume from this the constant pressure heat rejection can takes place in the evaporator and condenser. Then we can, for calculating the velocity, we can taking the datum. Okay, so the from the air column we can getting the datum, right? And then the evaporator, the condenser inlet temperature, the condenser's temperature, and then the evaporator temperature will be taken from these two thermometers. Okay, finally we can take an voltmeter reading and then ammeter reading, then energy meter reading. We will do an theoretical actual COP from this formula, and then theoretical COP from this formula. Okay, thank you.